Sam talk a little bit about Web 3.0, and hopefully he'll talk just a bit about, and actually to talk about this, but the fact that his company transitioned from edge computing to Web 3.0. So maybe if you could just say a little something about that, Sammy, about why you made that business decision to make that company. Sammy, why don't you go ahead and do a quick introduction, and we'll kick this thing off. Thank you.
Sounds good. Hey, y'all. Probably know a good number of you guys, even in person, because I've been like, I would attend this meeting each time I could. So thank you, Ed and Gary, for making it happen every month. Let me put this camera on too. Let me answer that quick question that you kind of asked, Gary. So Taubyte is built on Web3 technology from the beginning, though we were kind of like focused on edge computing and we still want, like, our target in edge computing is just there is so much noise in edge computing that it was just made more sense to focus on only Web3 right now from a kind of like a go-to-market strategy, because what we offer different than the hyperscalers and other players is very, very obvious. But that said, today I'm gonna talk a little bit about the role of the cloud in Web3, and the reason I want to talk about that is a lot of people in Web3 don't understand what cloud is, and they misunderstand it, or they just think that that's the thing that they just need to use, but they don't want to use. And a lot of people that understand cloud think that cloud and Web3 don't go together. So I just wanted to kind of like go through that and kind of like show you how we actually build a Web3 cloud at Taubyte as well, with a little demo at the end. That said, I mean, Gary, if I'm good to go, I can just kickstart the presentation here.
Please present. Go for it.
Okay, cool. All right, so let's start with kind of like giving like a high definition of cloud. So when you look up cloud, like there is no kind of like small definition of cloud, but the most important thing is cloud is a model. It's a model that transformed how we build software, how we deliver software, and it accelerated the internet and all those innovations that the big companies out there, like from Google to Amazon to all those companies out there, they are all enabled by cloud. Like I think Lyft's cloud expenses is about 19 million a month on AWS, right? That gives you like how much important cloud is. And like it's the most powerful model and innovation that has been around for the last few decades. That said, I wanted to quote Paul Maritz for something he said that is gonna unlock the rest of this presentation. So cloud is about how you do computing, not where you do computing. Now, with that said, like you have to unlock, like in your mind, that cloud needs to be centralized. You have to unlock in your mind that cloud needs to be in a specific place or a data center. And I think there is some feedback from the camera or your side, Gary. If you can mute it, that'll be awesome. Yes, yeah, that I think they'll make it better, hopefully. So yeah, that's kind of like the first thing that you need to do. Like, don't think as the cloud as being somewhere, or the cloud being a specific architecture. The cloud is how you do it, not where you do it. really. So now, what is Web3? Well, you'll find a lot of definitions out there, and because we're still building it, like every definition has a lot of bias. So some people will tell you like, "Hey, Web3 is about getting rid of all companies in the world and the user owning everything." But even when you look at Ethereum, most of like Ethereum is owned by VCs, and they make most of the decisions, right? So it's not really like decentralized. When you look at Bitcoin, most mining is done by 2 or 3 big companies, and it's not really decentralized. So my definition of Web3 is more like that I'm giving you here is more like high level. It could reflect in any point of view from a technical side or from a user perspective. So Web3 is a shift from hub and spoke model to a peer-to-peer model. Simple example, like instead of going to like AWS in this case and grabbing like EC2 instance, and that's AWS platform, you go to a network, which is Taubyte, and the transactions happen peer-to-peer. So whoever providing the compute for you, you pay and interact directly with that entity or that node or whoever provides that. Same for exchange, like you want to exchange USD for euro, like in the regular like Web2 space, you go to a bank and they do the exchange and take a lot of fees and stuff like that. Like on Web3, you go to a DEX, a decentralized exchange, and you exchange like your token, let's say Bitcoins for Ethereum. And it's almost like it's like most exchanges have a centralized part. I mean, that's for now, but there are like 100% decentralized peer-to-peer exchanges like 0x that are out there that allow like you to exchange token with somebody peer-to-peer without like a third party or like a central smart contract that's doing that or anything like that. So basically, we're transforming platforms into protocols and networks. We're going from a client-server architecture to a peer-to-peer architecture. We're going from master and slave or cluster leader when we have a cluster and we elect the leader in the cluster that makes the decision, to consensus and CRDT, conflict-free replicated data types. We're going from role-based access or anything-based access to encryption, right? If you don't want people to access your data, you encrypt that data and you give like keys to whoever need to access the data. And there are different ways to do that. Like there are ways to have multiple keys, like BLS, or like you can also just do regular asymmetric keys, like RSA or similar, like encryption, asymmetric encryption. So back to the cloud. The cloud implementation, because like how the web is being transformed, like going to like through all this transformation, like from platforms to protocols and networks and client server to peer-to-peer, from a lot of very little humans and very little like machines to billions of users and trillions of machines communicating between themselves. Like all of that make the current implementation of the cloud broken for that use case. So they're centralized. They require you to trust them. So centralized, like imagine like a smart city and all the data going to AWS in a central location. That's just crazy. They're also centralized in a way where AWS has control of that city. Like AWS could say, like, hey, give us this incentive, or we'll take down like your infrastructure or whatever you're hosting on AWS, right? And then the whole smart city infrastructure doesn't work anymore. And also AWS has control of the price. They can raise the price. They can do whatever they want. They require trust. So you need to trust AWS or Google Cloud or Azure or DigitalOcean or whoever hosting your software, that they're hosting your software the way it is supposed to be hosted, right? They're not altering your software. They're not modifying the libraries your software is linked to. They're not like sniffing on the network, like stuff like that. Like, how can you trust them? Like right now, you just say, oh, it's AWS, or oh, it's Google, or hey, it's Microsoft. We should trust them. And the question is, should we really? Like, those are the companies that are like using our data and making money out of the data anyways. So, I mean, I personally don't trust them. And the last is they're expensive to scale, right? Like you deploy something small on any of those clouds, and then you try to scale it to like hundreds and thousands of users, and then your bill go exponentially. It will grow exponentially, and it's very expensive. There is no competition. Like if you build on AWS, you're locked in AWS. And then if you try to scale horizontally to multiple regions, your bill like will double, triple, like depending on how many regions you go into. In addition, that like your cost of DevOps will increase as well, because managing multiple regions is very complex. Okay, so what kind of cloud we need now? Like, or how should we, or what are the characteristics of the implementation of the cloud that we need to have? So it's obvious that it should be usable and composable. Most clouds are already like that today. Most Web3 is not. So most Web3 is highly non-composable. It's very hard to put things together. So we need to have that part. It's very important. Very important to reuse. It's very important to have something that's composable. And I'm quoting here Chris Dixon from A16Z. So composability is to software as compounding interest is to finance. It's very important to have that in any cloud, in any infrastructure. Should be trustless. So trustless meaning like we establish trust using code, right? Or programmable trust. Quoting here Ali Yahya from the same firm. Again, like most of you guys know, that those guys are the biggest investors in Web3, like with the biggest fund and most money deployed as well. So crypto networks are a technology with the potential to catalyze trust and therefore cooperation at an unprecedented scale. They will help bring about a shift away from institutional trust into trust that is programmable. Or basically, programmable trust, or a protocol that establishes trust. And the last is fast and scalable. So it needs to be able to do a lot of things off-chain. You know, a lot of you guys know or having, like, when you think about Web3, you think blockchain, and actually blockchain is just a use case of Web3, not Web3 itself. And I think I talked about that before. And then blockchains are slow and will always be slower than anything off-chain because they need some kind of consensus. And a Web3 cloud should be able to do a lot of off-chain and should be able to scale to the edge and be closer to the source of data and to the users. So some Web3 people say like, oh yeah, I mean, cloud is centralized and we don't want that. And I already talked about that. Cloud is a model. It's not centralized or decentralized. It's really how you do compute in the best way you can. So it's scalable, it's flexible, it's composable. So and they will say like, hey, let's build something new. And I've seen some of those. Like there are some companies bringing like, oh, you need to learn a new language. You need like to build anything, and like this just like not scalable. Like how many languages we'll see out there, and how many different ways of doing things we'll see there, and that's just too hard and not scalable, because simply there are 26 million developers out there. They all understand cloud or the cloud model. Uh, there are very few thinkers that are Web3 developers that are willing to go to that extent and to like learning a new language and trying to kind of like build things with it without the certainty that's going to be around, without the ability to migrate existing technologies to that new language or new way of doing things. So yes, I believe the cloud is still valid, and I believe the cloud is the best way to go around scaling Web3 as well. And at Taubyte, we've built that kind of cloud. So it is decentralized, meaning it's a peer-to-peer network. It is permissionless, meaning like anybody can bring their hardware, their IoT devices, join the network, or spin up their own network as well. It's trustless, or trust minimized trust computing, meaning like nodes will communicate with each other using a protocol we call proof of integrity, and say like, hey, prove to me that you have integrity and I can trust you. And those are kind of like challenges that other node will run, and then provide a succinct proof, a ZK snark, if you guys heard of that. So it's basically like it doesn't provide like a whole, like it kind of like will prove to us that it knows some answers that makes it prove their integrity without providing those answers. So it's sharing the fact, not the data, and it's succinct, meaning it's very small, and that could be transferred around the network, saying like, hey, I trust this node because of this proof, and everybody can verify that proof very quickly as well, running like the circuit that attached to the ZK snark. And then ZK snarks or Stark or other ZKs are basically what a lot of what's happening in making blockchains faster, because like now nodes do not have to run smart contracts all the time. They can just run something that's way less expensive, which is verifying the proof as well. So, and there is also like that blockchain called Mina, where they kind of like have the whole blockchain inside 11 kilobytes, because 11 kilobytes is a recursive ZK snark proof, and the path to the transaction, and some other data that I forgot what it is, but basically it's within like 11 kilobyte, which is kind of like crazy. And then the last thing is fast and scalable. So I already said that like it should be off chain and it should be edge native. So Taubyte can run on servers, and it can run on small devices like IoT devices. We tried it on small IoT devices with 128 megabyte of RAM and an ARM5. So this is how small it can get. It can run on servers as well, and it's already running on both actually. Okay, so there's some screenshots. So on this side, like the left bottom side, it's the Taubyte console or web console. I'll walk you through this in a little bit. Those are some applications that were built on Taubyte. So in the IoT space, this is like a security, like remote security use case where they monitor using thermal cameras, like remote sites, and if there is a gas leak, the AI will detect that and then generate an event. The second one is firearm detection. So this is use case being deployed with school districts. I mean, you know what happened in South Texas. So trying to avoid that and alerting, police ahead of time automatically. And then the last is an example that we've built. It's a distributed Web3 chat that actually uses a lot of um, um, a lot of the services or resource types that we provide. So from functions to storage to key value databases to websites. So basically, I mean, it's a cloud general purpose. So you can build like blockchain oracles, decentralized protocol, NFT platforms, IoT platforms. I showed a few examples there, Web3 games, decentralized exchanges. You can do blockchain modifications and so on. So another thing is Taubyte is not API based. So when you do things on AWS, you hit AWS APIs and you hit Google APIs and Azure APIs. And what's happening behind the scene is not in your control. Like you don't really know how that definition is stored. Like you hit an API and then that's it. You have to kind of like keep your own way of defining things, like Terraform, for example. Taubyte is really based on Git. So whatever code or like infrastructure definition you have, it goes into a Git repo, and that's the source of truth. You have control of it. You own it. We don't keep a copy of it. We don't even know what's in there. When you push any changes, we compile it and distribute it in the network, and that's it. On the infrastructure side, so we have global presence. We have about 27 locations with more or less up to 10 nodes or 10 servers in each locations. They're not all provisioned yet, but we do have these locations provided by a number of partners that have infrastructure. We always welcome more. And I mean, just ping me if you're interested in spinning up Taubyte nodes because it's permissionless. And we're gonna launch a Taubyte coin in the few upcoming weeks, and then it will be a way to monetize mine Taubyte coins, basically. Okay, so the web console, it's like a very easy web interface that allows you to build on Taubyte. Everything you do on the web console really happens on a virtual copy of your repo in browser, and you have to push to your GitHub or whatever Git. For now, we support just GitHub, but later it will be any Git provider you can push there, and then we take it from there and compile it. But this is not like I said, this is not APIs being used here. This is really built in locally on your browser. You can do the same thing with other tools that I'll go through that we've built as well. So it's serverless. I'll show you in a second how to build a function. You can also host websites very quickly. We built more tools, so you can do the same thing you do with the web console with Tau or a regular code editor IDE. You can explore the network and see what's going on using Taucorder for Trekkies. If there are any Trekkie in the audience, the name comes from the tricorder. So just called it the Taucorder. And then Dreamland is spinning up Taubyte locally. So it's a ready to use command line. You run it, this will spin up a whole Taubyte network on your laptop, so you can test anything you build locally before pushing it to production. And that's it. So that said, if there is any questions, I'll be happy to get that, and then I can hop on and share like another browser window and walk you through a little demo here. Questions?
So what kind of platform maybe you?
Say it again.
What platform are you using?
What do you mean by what platform?
Is it R3 or Hyperledger or Ethereum?
Taubyte is blockchain agnostic. So whatever you build on Taubyte is off-chain. The coin that we're going to launch is gonna be a Cosmos-based coin.
So the underlying platform is it Ethereum?
No. It's not Ethereum. We don't run on blockchain. We're blockchain agnostic. The Taubyte blockchain that we're gonna launch is going to be a Cosmos blockchain, so it's gonna be totally independent and it's built specifically to account for compute and storage usage on the Taubyte network.
So in that case, then what would be the cost for clients or customers in terms of the number of nodes?
Yeah, so Taubyte is usage or based on usage. So you don't pay if there is nothing running, basically. But the cost is gonna be about a third of AWS. So if you're using AWS today, you'll save 75% doing the same thing. At least 75%. Like you'll cut your DevOps cost to zero, but at least you're saving 75% using Taubyte. Yeah. Does it answer the question?
Yeah.
Yeah. So like running a Taubyte function is like I think on AWS is 6 zeros and then a 6 or so, or a million call is roughly $1 or $2. So on Taubyte it will be a third of that, a million calls, right? So you cannot do that on chain. Like if you run a smart contract a million times, like that's gonna like be a lot of money. So yeah,
the fundamental value proposition of Taubyte is what is device management, IoT management, or is it data management from the IoT devices? What is it primarily? Or is it kind of authentication of the data coming from the sensors or any IoT devices on the blockchain?
Okay, so Taubyte is a cloud. So it's meant to replace AWS and Google Cloud and Azure. It is Web3 because it's trustless. It is peer-to-peer and distributed, just like IPFS or any blockchain. Where I mean, most blockchains today are not really distributed. They're mainly kind of like somewhat decentralized. But anyways, it's really distributed, just like IPFS, and we offer all the services that are serverless that you will find in any cloud. As we go around Q1, we'll also have like virtual machines and containers, which will allow us to kind of like offer like a full replacement of AWS or Google or Azure or any other cloud.
Okay, so you're running some kind of an agent on the IoT device to kind of
you install a Taubyte node. So basically, Taubyte nodes can be very small. So it's the same code that's running on a server. we can just cross compile it, or you can cross compile it, because we're gonna open source everything around sometime next year. But yeah, you can run it on an IoT device, and it's a full Taubyte node, and the IoT device will just like you can run WebAssembly functions, you can store data, and so on. It's just it will do it in a distributed way, just like IPFS, if you know what that is.
Mm-hmm.
Yeah,
like Filecoin.
Like IPFS, not Filecoin. Filecoin is kind of like IPFS with like a blockchain attached to it, and yeah, and proof of storage and stuff like that. But yeah, kind of. We do things differently. Like on IPFS, you cannot define like a bucket and how many copies you have and stuff like that. On Taubyte is more like a cloud where you can define your resources. Like, hey, you want to create a storage bucket, and that storage bucket has 3 copies minimum, and then we'll maintain that over the network, and so on and so forth.
I got a question, and I'm not a software guy, but if your network is trustless and you're going to distribute the source code, what's to keep bad actors from somehow corrupting it and causing a security problem?
Yeah, so there is 2 things. So the proof of integrity protocol that we're gonna do like a document. We're gonna publish a document soon about it. So basically, that's a very thorough protocol that is extendable as well. So it will check different things. Like if for me as a node, just imagine I'm a node, that there is another node. For me to deal with that node needs to provide me with a proof that they can be trusted, and those are like tests that they need to run and provide a succinct proof of them, and this is how we make sure that they have integrity. But if there is also another dimension to it. So every node in a network needs to stake Taubyte coins. And this is the purpose of us launching also like a blockchain. So if there is a bad actor and they keep having like failure proven integrity, or they've been proven to being bad actors, we're gonna like burn their stake. So they're gonna lose money basically. Does that answer the question?
You're basically going to be able to deny access.
Well, it's permissionless. So yeah, they will not be able to communicate or offer services. They might be able to get services, like there's nothing stopping them from getting services, but they will not be able to provide services, as nobody will trust them. And then they will also lose money because we're gonna like take their stake, basically. Does it make sense?
Yeah.
Any other questions before we start the demo? All right, let's go ahead and
Okay.
show us.
All right, I'm gonna stop sharing this screen. Gonna share another screen here. Actually, I'm gonna share it here. All right, you guys can see this. All right, so this is the web console. So it's console.taubyte.com. It's a single page application, and almost everything that happens here happens on your browser until you push. So I'm gonna just log in here. The email is for when you create a project. You don't really need this email. When you create a project, we need to push an email in the repo. So if there is a problem with the build or something, we can notify. But you really log in with your GitHub, because this interface needs to communicate with GitHub to create a repo if you create a new project, or grab like and clone a repo. if you want to edit a project. So here I have a couple projects that I created. Just gonna go ahead and create a new project. So I'll call it like IoT Happy Hour demo Dallas. It's gonna do private repos. If you do private, it's gonna be private repos. Like public, those are gonna be public repos. So as I create my project, it's going to connect with GitHub, create specific 2 repos. One is for config and one is for inline code. And then it's gonna open up that project locally, meaning like cloning those repos, and boom, here you are. Like you can see that I have no resources here in this like little note here. You can have a little README if you want. It's just an MD file. And Nick, there was just one commit, which was the one that created the repo. And you can see here, like it's just like this commit. So I'm gonna go ahead, and so you can see all the resources that we have. So functions, libraries, websites, storage, messaging, databases, domains, services, and smart ops. So I'm gonna go ahead and create an application that I'm gonna call like Ping, and that's my kind of like simple example of serverless function that we're gonna do here. So gonna go here. So gonna do an HTTP function. To do HTTP, we need a domain. So the first thing that we need to do is create a domain. So it's gonna be, I'm just gonna call it Ping domain, and I'm gonna generate a domain here. So it's gonna be a domain under Taubyte in here. So
Samy, can you increase the size of your screen?
we'll try. Okay, most of this is also documented in the Taubyte blog. So I'm gonna go here, add a function now. So I created my domain. So again, if I go here, you can see like I have like my domain here. You can also, if you have like your own domain, let's say iotdallas.org, you can use that as well. I just went for the easiest one here for like you to show the example. And then I'm gonna create a function, so I'll call it Ping, and we'll use inline code. And instead of typing everything, I'm just gonna use a template. So this template here, let me choose this domain. So the template here, you can see that it's Go. That's the language that we're supporting right now. The reason why we do Go, well, Go is an amazing language. It's almost as easy as Python, but it's also as fast as C or C++. Go compiles to WebAssembly. We love Go because a lot of what we do is Go. And we're the only one doing serverless WebAssembly in Go too, which gives us a go-to-market edge as well. So here you can see we're importing the Taubyte Go SDK, which is open source as well. So you can look at it and look at all the functions that we have. You can see there that we have Web3, we have IPFS, we have like databases and other stuff. But for the scope of this, I'm just gonna do something simple. So we're exporting Ping, and here we're gonna call Ping. So this is what when we hit /ping on the domain we created on HTTP, we're gonna run this function. So it's gonna, when we do Ping, it's gonna do like let's say reply hello, happy hour IoT Dallas, right? And that's it. I'm gonna save my function. So far, everything I did only happened on my browser. So what you need to do after this is push the code and the config. So that's the little button on the bottom. So you can see here on the config repo, I created an application called Ping, and this is the config of the application. I didn't put a description or any tag, but I do have a function which is the ping function, and this is the YAML of it, right? And then I also did a domain. Where is the domain? And I did the domain, and that's also the YAML of the domain, right? So all of this has been generated by the web console. You can do it manually using an IDE if you wish. You can also use the Taubyte command line or the Tau command line to do exactly the same thing. You can see that my code is here as well. Oh, my code is not here. Something happened. Hold on. Let me double check that I saved my code. Okay, the code is here. Okay, so I'm gonna push this again and do like first hit, finish. So this is going to push code and push config. So if I go to project details and I'm gonna open config repo, you can see that I just did a commit here. And this is the first commit that was automatically created. This is the automatically created, and this is my actual commit. And you can see the diff in here of what was added and all the files that were modified. I can also open my code here, and you can see here if I go to commits and I go to this commit, you can see the code that I just pushed. Right. So the moment I pushed, that generated an event that was captured by the Taubyte network, and that generated a build. So you can see that my config was successfully built, and you can see the logs here. And my code was also successfully built, and you can see the event here. Now, what we need to do is go to the application again. I'm gonna grab that domain because I really don't remember it. Gonna grab it and then put it in my browser and do ping. Okay, hold on. Let me push again. Might not have pushed code previously, or might be a fluke. I'll see. Okay, so each time you push something, jobs are created, and in builds you can see what's going on. So because it's a serverless platform, we also take care of building. Later on, you can also host your own kind of like builders. Right, so there you go. So push didn't go well first time, but you can see here, like I hit my ping function and it returns hello HHIOT dollars. Right. If I go back and modify my function, it will modify the return. Right. So if I go back to my function and say, like. I just added Gary here, right? You're okay with that, Gary, right?
Not really.
Okay. Sorry about that.
Keep my exposure on the internet down to a minimum.
Okay, so I'm gonna do another push, gonna generate new events, rebuilding config, rebuilding code. Obviously, code takes more time because it's generating WebAssembly. And by the way, you can also like download WebAssembly build. Like see here, like code. This was built already. If I click here, it's gonna download a WebAssembly file for me that you can look at and analyze. All right, so that's successful, and you can download this as well if you wish. We can probably do that in the layer if needed, but if I refresh here, it says Gary, right? this is not all you can do. So Taubyte website is hosted on Taubyte. This blog as well is hosted on Taubyte. And I have an example if you want to go a little bit more into like fun stuff and doing actually image rendering. This avatar is rendered real time. So it's a function on Taubyte. And I'll show you the code in a second, but you can copy this and call this function and do Gary. There you go. That's you, Gary. You're a tracking.
That's okay.
Yeah, I wish I could have like something like that, because this is randomly generated. I wish I got the tricky one. Like when I put my name, I get this evil guy. I don't know why. Am I evil? But anyways, for this project, everything around that project is open source. So I can close this project and go to examples. And everything is open source. The link is at the bottom for everything. So I'm gonna go back here and go to applications, and that's my avatar example. So if I go to this avatar function, you can see here that you can import any Go package, or almost any Go package into your function. You can also do libraries, but because this is a simple example, like not going there. You can extract like stuff from query or from post data body. So here I'm extracting like gender and username from the URL. You can see here like I have gender male, username Gary on the top of the URL. I don't know if you guys can see it well, but I do have it on the top. And then I'm basically doing some checks, and then calling the library that I imported, Go Avatar, which I didn't build. Somebody built it. I just use it. So it's gonna take the name, generate an image. We encode the image into a PNG, and then we send that over the network, or we send the bytes over the network, and this is how you end up with an image. So, and yeah, that's it. I mean, I have more examples in the blog, even how to host a blog on Taubyte. And actually, that's the Hugo website here. So this is how to host a Hugo website, and I have a blog article about that. And the Taubyte blog itself is also hosted here. So that's like the blog that you see here. This blog is basically this project. So I have one application, and it has a website. And the website is this one. So if I open the repo, so it's a repo using Hugo, and each time you push something, a Taubyte node will go into this little folder and then see like, oh, how should I build this thing? And then say like, oh, call build, and use the specific image. So in here, the image is defined with Docker, if any of you guys know what Docker is. So it's gonna build it, like use this container, or build this container if it doesn't know what it is. So it's basically a Hugo container that we add to it Git, curl, and bash. And then it's gonna run the build script here, and basically just run in submodule init to grab all the themes, update the themes, run Hugo to generate the website, and then move what was generated to out, and then the Taubyte node will put it into an archive and deploy it in the network. So basically, when you hit blog.taubyte.com, you're gonna hit a node, and that node will say, oh, I don't really know what it is. Network, tell me what it is. We'll say, oh, it's that CID. And then that CID or content ID will be discovered in the network. You will grab it and then serve it for you, and this gives you a nice website. And it's kind of like obvious. We're working on making it a little bit more obvious, but you can see here if I go to a website, look, I'm gonna do gonna share something here else. So this is the developer console. I don't know how much of you guys are familiar with the developer console. I'm gonna go ahead and go here. And then let's see if I can make it bigger. I can make it bigger. So what I'm gonna do is download the archive for the website. Just want to show you something cool here. So see here, like there is a request that went through, and it's this one. So it's connecting to Patrick, which is like one of the nodes that handle jobs, and it's downloading a CID. This is a CID v1 that also IPFS uses, right? So it's downloading the CID, and that CID basically is an archive of a website, right? So yeah, it's really like just distributed 100%. Yeah, that's kind of like. I mean, I can go deeper. Like the console can do branching and compare branches. You can do a lot more, and I'm working on more articles as well to cover all of that. Like here, you can like compare branches here. Right now, I have master, but you can create a branch. You can do branch comparison and way more. We have storage and messaging. Working on that. C3.cow.link is an example that like is using a lot of this concept. So here you can see like if a lot of you guys are connected here on the same room, we'll see each other. Those are past messages that are loaded from a key value database that's distributed as well. I think I don't know if you guys know OrbitDB, but it's kind of like an OrbitDB. It's a CRDT distributed database, and yeah, that's basically like a little tour here. Hopefully, you guys enjoyed it.
Good. Question. Yeah, go ahead. So Raj, yeah, I saw you do the Docker. Do you also support Kubernetes?
No. We have no need of Kubernetes. Taubyte can schedule jobs way better than Kubernetes.
The other question I had was, you mentioned that you guys are big Go favorites. In terms of hiring and recruiting people, what's your thoughts on getting resources for Go?
Say it again. Can you repeat the question? Do we have a mic, Gary?
Yeah, I'm saying, what's your thoughts on getting resources in Go? Developers.
Like developers for us, or getting the resources for developers to build on Taubyte?
If I were to use your application, I would use Go, right?
Yeah. For now, we support Go for backend. For frontend, you can use anything you want. We can host any website. You can port any actual website to Taubyte. For backend, yeah, it's Go. So basically, if you do look here, if we are doing our best to document our thing as best as we can. So if you Google just Taubyte Go SDK, it will take you to Go Docs, and almost every little thing is documented. So if you wanna use the IPFS client, we document it here. Well, this is an older push, but later today or tomorrow, we're gonna push some more explanation here. But I mean, it's pretty obvious as well how you use it. But that's one source, and the other source right now is the blog, and we're working on a documentation that we're gonna publish probably around next week with videos and stuff.
I think you asked an interesting question, because you need somebody that would know Go as well as kind of be a DevOps engineer.
Right.
Both. So you would have to have kind of both skill sets.
you don't need DevOps. So like you just like it's
Agree.
all.
Everybody that knew your platform, which is technically a DevOps job,
Exactly.
right?
Say it again.
Technically, learning the Tau system is a DevOps job.
No. There is no DevOps. We are a no ops platform. It's totally serverless. Any developer can build on Taubyte. So now, like for backend, you use Go. Go is a general purpose programming language that a lot of developers use. It's one of the most popular one, actually.
So I think maybe this question I was holding back, I wanted to ask later. Maybe this question will help us clear. What's the business case here from Taubyte perspective, right? What's your business case, business model? And what's me? I'm a consultant. I help customers get on the cloud and build applications. So how do I build a business case for my client to use Taubyte?
Yeah. So okay. So yeah, the business case is basically it's the same business case where you would use like AWS, right? So the advantage of Taubyte is we eliminate DevOps, contrary of what was taught. So there is no need for DevOps. It's like AWS Lambda, if you know what that is, but way simpler because you don't have to configure an API gateway. You don't have to do any kind of complicated configuration whatsoever. And then you don't have to manage regions. We deploy at the edge where your functions and when they're needed. So going back to what you mentioned, yeah. So any use case or business use case where cloud is needed, which is a lot, anyways, we can be there. Now, for us, really, we're focused on Web3 right now. Why we're focused on Web3? Because Web3 companies or Web3 communities are not enjoying using the big clouds because those clouds are centralized. They require trust, and we don't require either, right? And this is why we're focusing on Web3 right now. So if you're building, let's say, an NFT gallery, like most of them are hosting the gallery itself on AWS, right? If you're building a game, most of them are using AWS as an infrastructure. So all of that can be ported into Taubyte, and those companies are delivering a true Web3 experience to their users instead of a Web 2.5. But later on, as we grow, Taubyte will be on every 5G cell tower, will be on every IoT device, on every city and every home. Well, at least that's my vision.
Okay, so I have to ask a question. So I've been wondering why someone would go to the trouble to figure out what it is you're explaining here. And then you just said it will be on every IoT device. Is that what you just said?
Yeah.
There's billions of those.
Yeah.
And
Trillions.
everyone's going to do this.
Trillions.
And every one of them is going to do this.
Say it again.
No, you're saying that every one of the IoT devices,
No,
they
I said
will
my
have
vision
your
is
stuff or use your stuff. Is that correct?
no. What I was saying is my vision is every IoT device, every device will run Taubyte. Doesn't mean that it's gonna be like that, but just like almost every IoT device, or a lot of them run Linux, and a lot of servers run Linux. My vision, especially when we open source the whole Taubyte platform sometime next year, there will be a boost and an exponential growth where people can really adopt it way easier than ever before. And why should I go and use, let's say, AWS, which is not open source and relies heavily on AWS, where they can use something that has the network power or the power of the network, both from an infrastructure perspective and also from a engineering perspective.
So I don't understand engineering perspectives, but I understand business perspectives. And can you summarize what it is that you're, I don't know if it's I don't know to call it a product or a platform, but like everybody that does anything has skills that allow them to put applications live using AWS as a host.
Yeah. And you can do it faster and cheaper on Taubyte.
And say that again, please.
You can do it faster and cheaper on Taubyte.
Okay, so that's the real answer. It's a competitor to AWS that, so you deem it faster and cheaper, maybe.
Yeah, it's faster and cheaper. So you build faster.
Faster to learn how to do it, or faster
to learn, faster to actually build something on it, and faster to run as well. We did benchmarks. We do better than AWS, especially at the edge.
Okay.
And way cheaper. So you save 75% of the cost. That's not a little bit. And then you can actually, and this is the big difference, because that's what's different between Web 2 and Web 3. You can actually make money using Taubyte instead of spending money. So if you contribute, let's say you have servers and IoTs out there, and those IoTs and so, or some of them have good connectivity, you can contribute compute and storage to the network and actually make more money than you're spending, right? So or actually having like a
okay, so wait, making the money, I believe, is totally unrelated to how a product gets built. You make money, nobody in their right mind wants to own a 1/4-inch drill bit. There's lots of people that want to have a 1/4-inch hole in something. But so to make money is not related to the tools you use. So
well, this is not a tool. Yeah,
your product will be less expensive to use than AWS if you already have a way to make money using AWS.
No. That's not what I'm saying. What I'm saying is, because that was the easiest, closest thing to explain it, right? What I'm saying is, when you run compute and storage, when the Taubyte network provides compute and storage for you, you're paying the participants in the network that are providing that compute and storage. You're rewarding them with Taubyte coins, which translate to money, right? But if also at the same time you have nodes in the network, or you're staking coins with validators, right? The end result could be that you're not, like, you end up with a how we call that, like a nil balance at the end of the month, right? How much you're spending on Taubyte and how much you're making from staking comes up, let's say, the same, right? Or comes up actually greater if you're providing compute and storage as well, because right now when you deploy a server somewhere, that server is only doing your things maybe 1% of the time, and then sleeping the rest of the time. But if you monetize the rest, and Ed, correct me if you're wrong, last time or at some certain point you were talking about when you have a car, you can use blockchain to have that car monetize itself when you're not using it. Right, Ed?
So I think let me rephrase it. This is something similar to what you're saying is, if I had solar panels on my house and I use only certain part of that utility, and then the next, when I push it back into the grid, I make money. Is that what you're trying to say here? That I invest in the solar?
Yeah, exactly. Except that it's all automated through a blockchain, compared to kind of like going through an entity that's doing the bill and whatever. Right.
So
Taubyte is
actually,
pretty
when
close.
you're providing services, it's not in a centralized. I mean, like today you pay AWS for storage and data and everything else, compute. What I think I'm hearing is you're going to use the distributed model where every IoT device becomes a storage node and a compute node, and if you have extra cycles, someone else can be using it. Right?
Yeah, exactly, exactly, and not just any IoT device, any server, any compute capable device. Like it could be a server in a data center, it could be a server in a closet, or it could be, an IoT device.
So they would basically download the Taubyte client, and it would be running on the device and becomes part of the Taubyte grand
Yes.
compute ecosystem.
Yes, they will install the node, because there is no client server really. It's really a node. But yeah, they will install the node, and then having the node on their servers or their IoT device or wherever they want to have the node, they're now into the network. They can say like, hey, I just want to run my own code, and that's fine. But they can also give back to the network and monetize on those non-use cycles on their servers or IoT devices. They can also stake Taubyte coins. Like maybe you don't have servers and you don't really care, or you don't have IoT, but you can stake Taubyte coins and basically make money on that staking as well. I'll add this too. So the other advantage there is also Taubyte will be more accessible to places that do not have access to currencies that can be, used like with Visa cards and stuff like that. Like places in Africa and places like that. Like they cannot use dollars or euros or anything like that, but they can go on a decentralized exchange, get some Tau coins, and now host their websites and host their applications and whatever they built.
Any other last questions?
Yeah, is that the reason why you're implying this as edge computing? Now that I now that I have this extra compute cycle and resources, is that the reason why you are suggesting this would be an edge computing?
No. It's edge computing because Taubyte is edge aware. So we will. So when you do when I hit blog.taubyte.com, that goes to a Taubyte DNS server where we call Seer. It's actually a node that can act as a server, and any Seer node can act as a server, and you will reply with an answer. Right, the answer will give you the nearby nodes. And those nodes will be very close to you, right? So you don't need a CDN like Cloudflare or StackPack. Like with Taubyte, you don't need to pay for services like that, or Akamai, right? And then there is another part that I didn't talk about because we haven't released it yet. It's what we call smart ops. So smart ops is code that can communicate with infrastructure and make decisions based on infrastructure or provision infrastructure. So, for example, you can provision a 5G slice before provisioning your functions in your website, right, on the fly. And that's part of what makes it edge computing or edge native.
All right. No other questions? No more questions? All right. Well, let's give everybody